Welcome, everyone. My name is Dr. Cindy Ross Friedman, and I am a member at large of the Thompson Rivers University Faculty Association Human Rights Committee. Thank you all for coming out to hear this talk and for remembering that it's daylight saving. I just want to acknowledge and thank that we're on the traditional unceded territory of the Secwepemc people. Thank you very much. And just a couple of quick announcements. One, apparently there are some signs out in the foyer. Apparently you can take them if you think they're important and want to use them. I've just been given that announcement, so I'm happy to make it. The other thing I want to say is that there is going to be a film being shown next Sunday here in the Clocktower at 2 p.m. It's being hosted by the Council of Canadians in conjunction with World Water Day, and it's called Gasland. So that's next Sunday at 2 p.m. a film in here. Okay. Without further ado, I think I want to just get going. It's my great pleasure to introduce to you today our moderator from the Dean of Science here at Thompson Rivers University, Dr. Tom Dickinson. Thank you, Tom.
We're negotiating here. Are you going to get it up? Sure. One thing that I saw flash by in passing was the next notice of the next talk by Richard Boyce, President of the United Steelworkers, on April 13th. And the title will be The Reality of Having a Mine on Our Doorstep. So you forgot to mention that one, Cindy, or were you going to moderate it? Though you said you couldn't. I'm not sure if I'm here on the 13th.
Well, then I couldn't say anything.
So thank you very much, Cindy. My name's Tom Dickinson, as Cindy said, and it's been my pleasure to moderate 3 of these sessions, in addition to an information session that was run by KGHM last September. And the first one, we had to finish early because it was a Grey Cup game. The second one, we had to hurry up and tidy up quickly because it was the Super Bowl, and now Peter gets the priority. So thank you very much for coming along. And it's my very great pleasure to introduce a colleague and a friend as our presenter today, Dr. Peter Tsigaris. Peter's a professor in the Department of Economics at Thompson Rivers University, and he did his undergraduate and graduate work at Concordia University, where he met his wife, and he moved to Kamloops in 1993 with Leanne, and they have 2 small children. Well, they're bigger now. My son taught them, right, in swimming. Anyway, Peter's research interests are, I'd say, eclectic is a nice way of saying it. We end up periodically having discussions of games theory and economics, evolution and economics, ecology and economics, and we've shared a number of different discussions over the days on the interface between science, economics, environment, and other things. And Peter and I were chair and vice chair of the Thompson Rivers University Environmental Advisory Committee as well. He's published a large number of articles in international journals on all of these different subjects, and has attained I think a bit of a reputation for the excellence in his research in the economics department. Today, he's going to give us a perspective that matches with some of the other perspectives we've had. And the title of Peter's talk is An Economic Assessment of the Possible Health Impacts from Deteriorating Air Quality in Kamloops. Peter, thank you very much.
Thank you so much. Can you hear me? Yeah? Yeah, good. Thank you so much, Tom, for the introduction and the nice words about me. I just want to clarify that I am where I am by accident. I never thought I would be an academic in my life, ever in my life. So anyway, here I am now. My background in terms of my parents, etc. They lived live when World War II took off, and they were young, and therefore they didn't get educated if they wanted to, and they didn't have the opportunity to get educated. Anyway, so in terms of my family background, there's not a lot of people that moved where I am. So leaving that aside, anyway, I've been in Kamloops since 1993. I came from Montreal. Before that, I lived also in Greece. I was born in Montreal. We moved to Greece, and then I came back to Montreal, my post-secondary schooling, and here I am in Kamloops for the last 20 years. It's been incredible. I have my wife here. We adopted 2 children, lovely children from British Columbia, and we're enjoying our life in Kamloops, and we will continue to enjoy our life in Kamloops. Anyway, so that's. I can tell you a lot more about me, but it's important that we talk about the topic that I will be addressing. At the same time, I would like to acknowledge some people. Of course, my wife, because over the last 8 months, she's been hearing this story over and over again. New information was coming to me every day. So, Liana found out this information. Oh, I found out this information. Oh, this information. Oh, etc. And just to tell you that Cindy approached me about 8 months ago to give a talk on the economics of the Ajax mine, etc. And I said, Cindy, really, I'm not ready. I need time to do a proper work. And she said, okay, take some time. How about October? I said, okay, October. October, was it? Something like that. Anyway, sometime in the fall. And I said, so when the fall was approaching, I said, I don't think I'm ready yet. I don't think I've done all my research. I need more time. And she said, okay. Then, of course, all the rumors were circulating that, something was going on. No, there were no rumors. Peter decided that it wasn't time for him. So now the time has come. I think the time has come. And it's ongoing research, actually, because all this research over the last 8 months I've done, it will probably carry over for the next 10 years of my academic career before I retire. It's fascinating what I'm finding, and I'll find more information as I go. In other words, I am a PhD student again. So I came here to talk to you about an economic assessment of the possible health impacts from the deteriorating air quality in Kamloops. And I would like to acknowledge also Dr. Calder, because her inspiring talk a month ago motivated me to focus on the economics aspects of it in terms of the health impact. Also, I would like to acknowledge Dr. Bob Sumner, sorry for my pronunciation, who also gave me a lot of information in terms of the atmospheric aspects of the problem. Preston, my student, who did quite a bit of research for me, and a lot more probably I'm forgetting a few other people. But let me proceed with the talk. I get a little bit more comfortable as we go along, so bear with me. Are we all on the same page? Yeah? Good. I am an academic, and I'll try to level it down so the public can understand. I'm not going to put any sophisticated mathematical equations there or any economic graphs. It will be very simple. Okay? So let me start off by saying that we breathe air, right? And we want to breathe good air, and that's probably good air there, although there are probably aerosols and particles from air pollution that we can't see in there. But anyway, it's a relatively nice day. The air is not 100% clean, but it's not a bad day, to put it this way. And of course, we can move towards that direction and have a very bad day, which is basically January 24th, 2014, which there was an air quality advisory, actually the 24th, I think, on 2014, the air quality was pretty bad. We don't want to have too many of those bad days. We prefer to have the nice days. And there's a project one here that can lead to benefits from some kind of from the increased economic activity. Some project could be Ajax, could be some other project basically, but also can lead to air pollution with external costs, healthcare costs, ecological costs, and all sorts of costs. Costs basically that it's not borne by the firm or the market; it's borne by the community. Okay. And there's a project one, and that's what we're going to be looking at, right? Wrong. We're not going to be looking only at that. There's another path in life. And that path is going that direction. Instead of moving towards more dirtier air, because somebody told you that there are economic benefits, there's a path that takes you from dirtier air towards a better air. And there are economic benefits and costs associated with cleaning our air. If my house is dirty, I spend a lot of time cleaning it up in order to make it better, in order to enjoy it. I get benefits, but there is a cost because me and my wife have to clean it up. We could have enjoyed a glass of wine. So project 2, economic benefits and costs from cleaning our air. So which path should we take? Well, it depends on a number of things. The first thing that it depends on is basically, do we have too much of it? Is there too much pollution in Kamloops? The second thing that it depends on is basically, is our standard of living very, very high, or is it very low? If it is very low, then maybe we have to adopt whatever technology we have now to increase our standard of living and get better. But at the same time, pollute a little bit. China. But if our standard of living is very, very high already, of course, with associated problems, there's a lot of poverty sometimes. But a higher standard of living than other nations, underdeveloped nations, maybe we should be looking at path 2. Another aspect is how much do we value the ecological aspects of it, nature? Do we place a value of nature? How big are the health impacts? Do we value safety? There's a few other ones, but, of course. What image do we want for our town? Which was brought nicely by former Mayor Mel Rothenberger. And of course, Dr. Rob Hood and Dr. Rob Hood and Dr. John Hall. Those are important elements of which direction your community wants to go. Our community wants to go, excuse me. Okay. With me? Good. Let's go back to project 1. First problem. So this new project basically in economics creates this consumer and producer surplus. Consumers' happiness. And producers' happiness for producing the copper, the gold, this thing, whatever it is. Okay? Because society values it. But at the same time, these projects can impose this negative externality in terms of possible health and ecological impacts. Okay. So it's a benefit cost. You cannot ignore the social cost. Let's go back to this proposed mine, the net benefits. I'm going to spend just a little bit of time on this side of the board, because on the left-hand side. I'll go to the right-hand side soon. Okay, so we have basically some benefits arising from the expansion of the supply of copper and gold. And who will benefit from it? Consumers, because they need the copper, right? And how will they benefit? Well, the expansion of the supply will put pressure on the price of copper to get lower. More supply, same demand. I'm not changing anything. Therefore, they'll be a lot happier. When you go shopping and you find the prices lower, you are a lot happier, aren't you? I am. My wife is, well, I'm not sure about me, but my wife definitely is. Because I'm not sure what they're selling me when they lower the price. But anyway, that's a different question. My students always say he's funny. I don't know if they're learning anything, but he's funny. So the consumers will benefit. The benefits will come from the lower price. Now, at the same time, the lower price will affect all existing producers in a negative way, because they will get a lot less revenue. Highland Valley Copper, New Gold. They don't want these guys to come in and expand the supply. Why would they? But I'll call that a transfer. In other words, I'll put a dollar figure, because I don't want to take sides on the consumers or not. So I'll put a dollar figure for every dollar of one person losing to another person gaining. Okay? So consumers gained, the existing producers lost. Therefore, there are not a lot of extra consumer benefits from this small expansion of supply. The supply that will expand is about 47 tons of copper. That's 0.3% of the world market. 0.3%. Not a lot. At a lower price. I've calculated, but I won't tell you the number. Not a lot. The other element is called this net present value. It's the producer surplus. It's the revenue that the firm will get. And the revenue that the firm gets, it gets it from the consumers that buy the product. And it's in a way, it's offsetting. Minus the cost of producing copper. All cost of production. Not only labor. Labor is a cost, by the way. It's not a benefit. The cost of capital. The firm will put $1.4 billion into this investment. They can take that money and put it in the S&P 500 and get a 7% return. Therefore, this project has to yield them more than 7% return in order to put the money here. I will subtract that from there, because that's an opportunity cost to an economist. The money can go elsewhere. The cost of using energy, the cost of using water, the ecosystem. They're using nature, and nature produces ecosystem services. That should be incorporated in there. It's not, because the economic system doesn't allow it to be in there. And the health impact. Why should we pay for it? But if I include all of that, there's nothing left for them. Net benefits, of course. The revenue that they get, and where do they get the revenue from? Well, they get it from the producers and the consumers. So it's a transfer. But of course, they can use it for public good, for provision of public goods. And community. That community has confused me. There is one benefit, and that is the donations and the philanthropy that the mine will give to the community. The other stuff is complex and mixed. It's complex and mixed for the following way. I don't have a counterfactual to evaluate it. If the mine comes in, the mine comes in. It provides whatever the benefits are. But if the mine does not come in, something else happens. And that something else will lead also to growth and benefits, etc. It's the net effect that matters in economics. We need the counterfactual. We don't have it. I'm not going to spend time on this particular aspect. It's the same way as medicine. You have a treatment group, you give them drugs. And you say, oh, look, 6 people out of 100 are much better with the drug. So what? You need a control group. You need a counterfactual. You need something else to compare it, the status quo. maybe 10 people are better off with the status quo out of 100. You need to compare. It's not an absolute value. It's a relative term. And of course, it's pretty risky. It's a sector that goes through booms and busts. So the benefit side is not very clear to me. And please, if you want to ask me questions specifically about the community and the counterfactual, I can address it during discussion period. All right. Here are some community costs. Well, there'll probably be air pollution, particulate matter, leading basically to respiratory and health illnesses, hospital admission, premature death, children at risk, school and work days missed. Gee, I cannot believe it. What time is it? Okay, good. I cannot believe my child, my 14-year-old child, is very extremely healthy. He never gets sick. We say to Leanne, Alexander, my younger one, always gets sick. He'll feel flu, etc. Well, this winter time, I was reading the Environmental Protection Agency paper from the U.S. and I was reading about acute bronchitis. So I was reading the symptoms. Eric was coughing in the other room and not breathing and having fever. So I was reading the symptoms and I said, Eric, let me read you this. So I read the symptoms. I think you have acute bronchitis. She says, I don't know that. I said, I better take you to the hospital tomorrow if it continues. And then I take him to the hospital. Lo and behold, he had acute bronchitis. Wow. So there are economic costs of possible health impact. And of course, there are these ecological damages. And I'm not going to spend time on ecological damage, but I can tell you a lot about those too. Because they're very significant. They're not minor. Nature has become scarce. And when nature becomes scarce, it commands a price. But we have no price on it. All right. So the question is, which one is higher? Clearly, the community costs are there. At least the ecological damages, maybe the other ones, I don't know. I don't know. There must be there too. So that's the situation. Project 1. To me, I'm not sure. I'll tell you more about it. What I'll do is basically, the purpose of the environmental review process basically to examine this side. They don't care so much about that side. They're very interested whether these are high costs. If they're high costs, they will not get the permit. The mine will not get the permit. If those are low cost, they will. All right, let's go to project 2, cleaning our air. I love it. And there are net benefits. I guess I should say net benefits. There are benefits from arising from cleaner air. Right? Oh, sorry. Oh, no. Gee. Oh, no, I made a mistake. Oh, Leanne, I told you not to put those there. There are the benefits. Better nature. Jackal Lake. Go and have a nice outdoor activity. Oh, look at those guys. The benefits arise from avoided health and ecological impacts. The benefit arises from not giving nurses and doctors more jobs. Community benefits are very clear here. Sorry. Right? Cleaner air. There must be community benefits, better lifestyle, better quality of life, etc. All right. Cost of clean air. You want to see some cost of clean air? There must be cost, right? We have to sweep the floors. Abatement technologies, we call them in economics. Bag houses. They take dirty air, they filter it out, and the clean air comes out. Efficient fireplaces, electric cars, natural gas buses. And it's good. I congratulate the mayor for taking an initiative there with Minister of Transportation Todd Stones and getting us 25 buses that are a lot cleaner relative to diesel. Parks, trees, solar panel. We have so much sun here. Well, not in the winter time. I'll tell you more about that later. Scrap copper, because we need copper to produce these things, a little bit of copper. So let's get some scrap copper as opposed to dig a big hole beside our town. And taxes to change behavior. I'll come back to it. We might need a municipal tax on gasoline. It can definitely generate much more than $360,000. So which one is better? There's a study by Environmental Protection Agency in 2011, EPA in the US, that looked at the environmental regulations that occurred in 1990. And they said, well, if these regulations are in place, these are the benefits, and these are the costs, relative to not having the regulations in place. Always relative. An economist always talks in relative terms, never in absolute. So those pamphlets are absolute values. They're not relative values. What do they find? Benefits, $2 trillion. That's only 1 year, 2020. They looked at $2 trillion and the cost $65 billion. A ratio of 30 to 1. Oh, isn't that a better project? I would think so. There you go. An economist that says clean air is good economics. I found it probably from a child. Okay. Project 1, back to project 1. Open. What time is it? Good. I might go a little bit further, but it's okay. I'll keep you on your toes, I think. I do it with my students. Open pit mines too close to a large urban area can cause this increased air pollution. It can add to greenhouse gas emissions. It can cause possible noise and air blasting issues, possible water contamination issues. The top one is a Yukon mine that got approved in June 2012 beside Whitehorse with a population of 26,000. They told them, hey guys, look, no noise at nighttime. As quiet as a library. The other guys are in Arizona, Saharita. This was posted in January 2010. Population 26,000. The mine is 10 kilometers. The mine is 10 kilometers from the town. And they were upset because they're blowing dust. Everything will be okay in Kamloops, of course. Okay. We have a topography that is not conducive to air contaminants. It's in a valley. It creates inversions, especially in the wintertime, where cold air is below, followed by a warm air level, then followed by cold air, etc. The warm air in there contains the air contaminants in the valley. And those are called inversions. So it sticks inside there, and especially occurs in the wintertime. And then, sorry, they're upside down. They're upside down on purpose, basically, because the city of Kamloops is down here, therefore the city of Kamloops is up there. Therefore, the mine faces the city. And you can get this blowing dust, especially with southern winds coming down, katabatic type. Katabatic means down. Thank goodness I'm Greek, so it comes from a Greek word. Means going down the hill, finding a path. The wind finds a path through the creeks and comes down. I live in Peterson Creek. Let me tell you, in the wintertime it's quiet. When spring comes, they come down, and they come down pretty nasty, and they whistle. It's a very lovely, romantic time to hear the whistling wind blowing down the creek, going down to the hospital downtown. As long as, of course, there's no stuff in there. But it also can cause haze and fog, and again, keep the air contaminants down there. There's a type of katabatic winds that can arise. This is by Dr. Schirmer provided. Bob, I'll get your name right one day. Schemenauer, thank you. Schemenauer. And there's the paths that these katabatic winds can take into the city from the mine, arising from the mine. I don't know how they're going to be controlled, but they're southern and they go through creeks and paths. They find paths. And there's my place actually, and there's the creek there, Peterson Creek. I like it now, but I'm not sure I'm going to like it when the mine is when the mine is there. But let me go down to downtown neighborhood, downtown Kamloops. If you look at the demographics, the population, the red is the female, the blue is the male. You can see basically that. Oh, where's that thing? You can see that there are not a lot of kids downtown. You know, the population is mostly of older people, and they're the more vulnerable. And you can see there's a lot of nice older ladies, 85 and over, about 200, and all those males are gone. A lot of males are gone here. But in general, it's the older generation living down there, and there's a few young generation too. But anyway, that's not conducive to them. It leads to they're already old. It leads to further respiratory problems, etc. And if you go to the Aberdeen area, you can see that there's a lot of younger kids, and not too many older people here. And of course, that could have consequences of the air particulate matters traveling by the wind going into their development lungs, etc. I don't know. But anyway, let me focus on particulate matter air pollution. This has gone to, Dr. Calder already mentioned this stuff, but just a little bit of I guess, a refresher. It's basically a pretty complex pollutant. It's not, it's mixed together with many other elements. And they're very tiny, they're very small. The human hair diameter here is 50 to 70 microns in diameter. That's my hair. I can't pull out a hair from my, but in general. But you can see basically the PM10 is basically, I would say 6 times smaller. And this one is even 25 or so, whatever it is. A lot smaller than PM2.5, which basically comes from combustion particles, and PM10 could come from dust, etc. And where does it go? Where does it go? Well, it goes right into your respiratory system through the nose and throat and through the etc. mouth. Some of it is eliminated by sneezing and coughing, and a lot of the smaller ones, the PM10 and the PM2.5, can go deeper into your lungs, especially the 2.5 can go really deep and cause lots of damages. All right, where's the source? Well, wood-burning stoves, power plants, heavy-duty diesel engines, natural sources, cars and trucks. They call those tractors there, the non-road vehicles. Forest fires, are they natural? I'm not sure anymore if they're natural. We call them natural. Siberia, huge forest fires. Intensity of forest fires has gone up. California, forest fires, lots of them. Climate change, global warming, impact, a human finger, could be. So let's not call it always natural, because some of it might be natural, or human caused. Industrial sources, space heating, what's that? Anyway, etc. And again, it goes into our body. So it's basically our lifestyle and existing technology. addicted to it. Status quo. Okay, possible air pollution from the proposed mine. Well, I didn't know a lot. I learned a lot from going to Tony's tour. You blast. You take it. You put it on trucks, load it up in trucks. You move it. I was going to bring a truck here full of earth and just dump it and see if we have create any dust, fugitive dust. You then blast again, take out rocks, move the rocks, put them on a waste rock. Then you take the ore, you crush it, you screen it, you process it, you ship it, you grind. No, before you ship it, you grind it. No, don't you grind it? You grind it a lot because the grade is very, very low. So you got to grind it very, very fine. And you use a lot of energy and a lot of water to do that. And then you put everything into the tailings pond or tailings facility, whatever they call the rest, the remaining. And then you ship the rest away. This is from the wardrobe feasibility study for the Abacus Ajax mine. The project is expected to generate criteria air contaminants from surface disturbance and fossil fuel combustion during construction, operation, decommissioning, and reclamation of the project. Fugitive dust is expected to be a major emission relevant to air quality and primary concern for nearby residents. That was in 2011. And of course, you have also diesel pollution. All right. Here are the PM guidelines. World Health Organization, less than 10 micrograms per cubic meter. BC air quality for PM 2.5, less than 8. And their planning goal is for less than 6 micrograms per cubic meter. Again, I'm calling them guidelines because they are guidelines. They call them standards, but they're not standards. They are guidelines. They are standards in the US. And they are standards in the US. The standards in the US are higher than that, a little bit higher. California has 12, US has 15 on an annual basis. And if you don't meet it, you are fined. In Canada, if you meet it, if you don't meet it, it's guidelines. Don't worry about it. I did it by myself. I went into the BC air quality, and sorry, radio, and all I'm here. Hope you can hear me. And I did it for 365 days, day by day, 24, day by day, and then I calculated. It came out to 8.9 micrograms per cubic meter, and it's verified by other. But same thing in the Brocklehurst area. It's 9 in 2013. Well, is that high? I don't know if it's high or not. It's higher than the guidelines. And it's higher than Vancouver, who has a population of over 500,000 population. It's higher than Calgary. It's higher than Ottawa. We're beating Montreal, and we're beating Toronto. Well, it's about 2006 data, but still. So the topography of Kamloops does not support air pollution or air contaminants as much. We're only 90,000 people. All right. Winters are bad. They're really bad. If you look at January 2013, I calculated at 14.11. February 2013, 9.8. March, it's getting better, guys. It's going to get better. April, 6. May, 6. June, 5.5. Oh, forest fires are probably starting here. 7.3, 6.7, 7.58. And then we're going to winter. 8, 14, 11, 11. The average in the winter times is 12.5. I'll hang it. And February 2014, it was calculated at 8.4. So winters are really, really bad in Kamloops. Summers are pretty good. In terms of particulate matter. But then in the summertime, we have ozone, low ground ozone. Because in order to create low ground ozone, from my understanding, is you need sunlight. How much sunlight did we get this winter? Nothing. So therefore, in the winter time, in the summertime, if the particulate matter is low, ozone comes into play. I haven't calculated enough time, sorry. And when you put the air quality index, it takes the average of ozone, what ozone it is, and what particulate matter is. Therefore, it averages out, one high, one low, something in between. Oh, you guys are doing not too bad. Well, we're not as bad as China. Let me skip up. Okay, so air pollution is caused by natural and human anthropogenic activity. Kamloops PM 2.3 is 9 about. That's with the North Shore. Goose Lake is 3 about, give or take. So Goose Lake, nobody lives there anyway. There's not a lot of activity, not a lot of industry, etc. So it's around 3. So what's the difference caused by? Must be caused by us. Our activity, our industry, our lifestyle, etc. Right? All right, I'm going to take you somewhere where you've never been before. Or some of you have. This is the sources of total particulate matter. In other words, all the stuff, all the particulate matter, the coarse, the less than 2.5, and the more the bigger ones, the ones that are bigger than 10 microns. Okay, and the data are available to anybody to access. It's through the National Pollutant Release Inventory. Sorry, I'm going to get into the economics, but we'll have to find out whether we have enough. We have a lot of pollution before we get into the economics. They have data for each company. In 2012, it's in tons annually. It's across Canada, and for the total, there's 1,073 firms that reported their particulate matter and the type. Are you ready? Okay. Highland Valley Copper, it's an open pit mine. The total was 8,537. It was fourth across Canada in terms of level, and it was fugitive dust. New Gold, sixth. It's underground, and it surprised me a lot. 5,580 tons. Fugitive dust. Sixth overall. And 2012 was not a full year. 7 months was a full production. The first 5 months, they were not in full production, my understanding is. Domtar, 893, 34th, and stack emissions. Lafarge, 272, 111th, stack and fugitive emissions. Tolko Industry, 112th, 213th place, stack and fugitive emissions. I calculated that by myself. I'm not sure if it's the correct one, but we also, with our lifestyle, we also emit particulate matter by driving our cars, by wood-burning stoves, by fugitive dust, etc. And I estimated based on the US average household figure that I got. So I assume that level. And there's also emissions coming from the highways. We have highways in Kamloops. And there's diesel trucks, big diesel trucks that go along the highway. And they go through Valley View, up. They dump some of the stuff to us. I have not come up with an answer yet there, but I am reading a study done in London, and it's significant. All right. Let me go to the PM10 and lower. Yeah. Right. Okay. Good point. Now let me go to PM10 and lower. Thank you. 3,350 firms reported. PM10 and lower are the nasty stuff. 2.5 is even nastier, but PM10 is pretty nasty. Highland Valley Copper, 4,408, first place. Southwest, 33 kilometers by air. 75 kilometers by taking the road, but pollution doesn't take the road, it takes the air. But probably, who knows? Probably we don't get any of that. It's pretty far away. I don't know. I don't know the atmospheric stuff. But it's there because it's an open pit, and to compare it with Ajax coming in. New Gold, 1,818, 7th place. Domtar, 611, 29th place. Let me tell you something about Domtar. It's quite important. But I'll tell you when I get to 2.5. Lafarge, 169, 119th place. Tolko, 35th, 306, and emissions from highway in progress. Here's Ajax. It's in progress for me. But Ajax is next door to New Gold. They're apart by 4 kilometers, maybe 5 kilometers, from one end to the other end. From pit to pit, they're about 8 kilometers. But I'll come back to it, because really what we're talking about is not Ajax, but what we're talking really about is a Highland Valley copper, an equivalent to Highland Valley copper beside us. Ajax and New Gold emissions probably will exceed Highland Valley copper's emissions in particulate matter. Let me go to the 2.5. Highland Valley copper, 2,152, second, again far away. New Gold, 1,717. And they're not in full production yet in 2012. They weren't in full production. I don't know. Domtar, 454. Domtar was 690. Domtar has come down a lot since 2010. In 2010, they got $57.4 million from the federal government to clean their act. Mayor Peter Middlebar got a letter on February 4th. You can find it online, search it. By luck, I got it. Who told them that we are coming down, and we'll come down by 70% in 2015, in 2015 relative to 2010 levels. And they have. And closing the A line has helped a lot, of course. But they're improving their boilers. They were at 690 last year. Lafarge 74, Tolko 4, and Ajax in progress. But again, if New Gold emits 1,717, add New Gold next door, to the east, one to the west, one to the east. Doesn't matter which way the winds will blow, as long as they blow south. All right. Top 100 PM 2.5 emitters across Canada. I didn't put everybody because there's a lot of small firms that emit a little bit. But they add up, of course, right? But here's Highland Valley Copper, here's New Gold, and here's Domtar. These are top 100 PM 2.5 emitters across Canada. All this data is available for anybody. National Pollutant Release Inventory. It's available to the public. It's available to academics. It's available to everybody to investigate. It's a big database. It doesn't have only particulate matter. It has all sorts of other air contaminants. Oh, this one here? Oh, okay, sorry, yeah. Okay, I forgot. My wife told me. Explain the graphs, Peter? Yeah. Saguenay, Quebec. And this is the frequency, how many you observe. So you observe a lot of those are 100, about 65 of them emit less than 400. Okay? There's about 18 here that emit around 400 tons of particulate matter. About 18 firms. So we're going 70, 68 plus 18, we're approaching 100. And then you see that they get smaller and smaller and smaller in terms of number of firms as the amount that they release increases. It's called an exponential distribution. It drops fast. You'll see it again and again and again. But it's good to clear it now. Okay? So there are not a lot of firms that emit a lot. And there's a lot of firms that emit a lot less. Okay, I'll skip that. Just to show you basically the extent of what we're facing here. This is Kamloops. Where's Kamloops? There's Kamloops. There's my house somewhere here. Here's the Ajax property. There's the New Gold property. There's the city limits. There is another picture of Highland Valley copper. And as I said, about 33 kilometers by air. Pretty big. But if you remove the tailings here, the tailings pond here, this side, and you leave this side, well, it's getting close to about the same size. Let me put in the Abacus mineral claims. When you put the Abacus mineral claims in there, and I heard that Ajax also bought mineral claims down here also recently. Well, you're looking at basically a Highland Valley copper beside Kamloops. You cannot treat it in an isolation. Environmental review committee, whoever you are, comprehensive or non-comprehensive or gold standard or whatever, this cannot be treated in isolation. It's huge beside a big town like this. There's Domtar. Told you that they're doing a good job. And you should be moving that way too. And we should be moving that way too, as a community. Cleaner air, you saw the benefits. And there are jobs on the cost side. All right. Let me go into a little bit of a health impact stuff, the one that Dr. Caldor talked about. Particulate matter and low ground ozone causes premature mortality and morbidity, illness, disease. It's scientifically sound, peer-reviewed by the medical profession. It comes from these epidemiological studies. They follow cohorts. They follow 8,000 people over a 20-year period. They record what the situation is at the beginning, and they follow them. And some live in dirty cities, some live in clean cities, and then they check to see what the impact is of a change in PM 2.5 or PM 10 arising from. And they find basically in terms of premature mortality that if you increase PM 10 or PM 2.5 concentration by 10 micrograms per cubic meter, premature mortality increases by about 14%, the incidence. There's short-term and long-term exposure. Short-term and long-term exposure causes health damages, and there's no safe thresholds. In other words, none is better. And this is how they come about. They do these studies. They control for all other factors. And here they have the PM concentration. And here they have the incidence, the mortality rate, let's say, or the disease rate, or whatever it is that they want to estimate in terms of the incidence. And they log it to make it linear, because usually it's non-linear. At very, very low levels, changing a little bit the particulate matter increases the risk a lot. If you are at very, very high levels, you already are, chances are that you'll probably die prematurely. So smoking on one more cigarette, so what? But if you're not smoking a lot, then you smoke one more, be careful. But anyway, that's why we take the log basically to linearize it. And then we use that. I'm going to use that later on. And for 1 microgram per cubic meter, it's 1.4. For 10, it's 14. Okay, I'll come back to it. All right, health impacts from air pollution. Okay, now we're going into a little bit economics. Well, you have lung function problems, you have inflammation, you have cardiac effects. I'm putting down here the proportion of the population affected and the severity of the effects. Then you get into respiratory symptoms, medication use, asthma attacks, doctor visits, school absences, lost work days. I got through, with my son, I got through all these ladder here. And I went to the ER visit, so almost there. But thank God I didn't go to the last part. Premature mortality. and research the Environmental Protection Agency, and I'll show you a few, shows that 80 to 90% of the costs are there. That does not mean that the rest is not significant. And it could be underestimated. Because there's suffering and pain that is not included in there. Premature mortality, oh, well, we died. The people that are left over probably suffer more than the person that was diseased. But anyway. How do we measure, how do we put a value on premature mortality? Well, these economists, they come up with this concept called the value of a statistical life. And it's basically, it's controversial in a way. But it says the following, it says, how much people are willing to pay to reduce the risk of dying prematurely before their time. And way and behold, people are willing to pay a lot. It's the value we place on safety. We have airbags in the car. We have seat belts. We put our kids on a car seat to protect them. From what? From injury. If we didn't have those things, the car would be cheaper. We're paying for those things. We pay our city property taxes to protect us, to keep us safer. Because we value safety. You can think of it the opposite way. You can think of it as a willingness to accept a payment to take a little bit the risk of premature mortality. In the labor market, they do it often. If there is they find in labor studies, basically, that if there is a fatality risk in there, after controlling for all other factors, experience, etc., all the other elements, experience, education, whatever they are, once you control for all other factors, fatality risk is positively associated with wages. The more risky the job is, the higher the company will pay you to attract you to the company. And you say, okay, sure, I'm holding an explosive. Gee, pay me more. It's the value we place on safety. The median value from 30 US labor market studies is 7 million. 30 US labor market studies. And this is by Harvard guy, Viscosi, in 2005. A paper he wrote on the value of safety, or the value of life. EPA estimates at 9.1 million. EPA is the Environmental Protection Agency. And the Food and Drug Administration in the US, 7.9 million per life saved. Okay? If you want to think about it this way. This is a nice picture that I got from the EPA's site. Think about a population of 10,000 people. We invested here in a water treatment plant. Why did we? We want to be safe, exactly. And we pay for it. We're willing to pay to keep us safe. Before we had the water treatment plant, we were still spending money. We were spending money to keep our water in our house cleaner. So, in a population of 10,000, suppose that you want to reduce pollution, and that would avoid 1 premature death. So there's this red dot. I hope it's not me. But it could be anybody in here. So we want to eliminate that chance. And everybody gets together and says, well, on average, I'm going to be willing to pay 500. Some 1,000, some none because they don't have enough income, etc. But on average, 500. So if you take the 10,000 and you multiply by 500, you get $5 million. That's the value of a statistical life. Okay. All right, let's go to 1990. What time is it? Good. I'll keep you another half an hour, and then we can have question periods. It's important because I have more to show you. My research. The research I've done over the last 8 months. This is a 1997 EPA study. It's a benefit cost analysis. It's the US Clean Air Act. And they were required by Congress to evaluate the 1970 and 1977 amendments, regulations to this Clean Air Act that came in 1963 in place. And I said, hey guys, we're spending a lot of money, the industry is losing money. What are the benefits? Are there any benefits to environmental regulation? And the period of study was from 1970 to 1990. It was peer-reviewed by a scientific advisory committee of Congress. Are there benefits to these regulations, or are we just imposing a higher cost to the industry with no benefits? All right, this is what they found. This is the black lines are this is the air contaminants, total suspended particulate, sulfur dioxide, nitrogen oxide, volatile organic compound, and carbon monoxide. And no control is if you let the economy grow and put no regulations. And the one is the control one. So this came down quite significant. These ones came down also, and the carbon monoxide came down. What did they institute? Well, those catalytic converters, which convert basically these the air contaminants into carbon, and there's less of this stuff. What else did they do? Well, remember lead, right? They removed lead. No more lead. Okay. Again, hey, don't forget jobs. Somebody has to create this catalytic converter. You're creating a whole new industry, but in the clean sector. Oh, you got to change all those gasoline stations, etc., and the refineries, etc. That's a lot of more work. You're losing some work, you're getting some work. And of course, they imposed national ambient air quality measures, standards, that were required to be met. If they were not met, you would be fined. Penalties. Standards with teeth. Oh, what's the other one? Well, and scrubbers for sulfur dioxide. All right, what are the benefits? $17.9 trillion, discounted at 5%. Now that's a very high discount rate to use, to tell you the truth, for health impacts. But that's what the government requires them to use, 5% discount rate. Because these benefits will accrue over time, right? Over 20 years. So a dollar today is not as good. The dollar today is a lot better than a dollar tomorrow, right? When I ask my child, do you want a candy today or a candy tomorrow? He says, no, Daddy, today I want the candy, not tomorrow. Don't wait tomorrow, please. And how did they get that? Well, they estimated that there will be 183,000 lives saved. And each life saved was worth $4.8 million. Do the math and you'll get about $17 trillion. And there was chronic bronchitis. IQ avoided being lost because they removed lead. So American kids people were smarter or not worse, not as dumb. Hypertension, hospital admissions, respiratory symptoms, pneumonia, ischemic heart failure, shortness of breath, acute bronchitis, asthma attacks, etc. They amounted to 4.2 trillion. Okay? So what? What are the costs? Benefits of a cleaner air, $22.1 trillion. My favorite picture from the campus mom for a healthy environment. I love that picture. What would the cost? $500 billion over 20 years. Peer-reviewed. Let me go quickly through this study because I want to get into the campus area. Second prospective study, they did another study in 2011. And I showed you the benefits were $2 trillion and the costs were $65. Well, what did they attack there? In 1990, they said we're going to attack smog. We're going to attack also sulfur dioxide because we want to attack this acid rain problem that we have. And they used permits, actually, and they did a good job. We don't talk about acid rain a lot anymore. And they didn't attack too much fine particles, the direct ones, because there are indirect particles coming out. The indirect particles come basically from these guys here mixing up with these guys. Some chemical reaction up in the atmosphere. I'm not a chemist. I'm not an atmospheric but they create secondary particles. But they attack smog, and smog is caused by these guys, and sunlight. That's my understanding. I'm not a scientist, but my last time I took science was in high school. And here's what they expect. This is from 1990 to 2020. They expect that this is the reduction here. So the darker, the more will be the darker the color, the more the reduction. And you can see basically LA. They're expecting a lot better in terms of PM 2.5. The eastern U.S. also a lot better. And of course, these guys really are clean anyway, so they don't need a lot of cleanup. Visibility from clean air. I'm sure you would enjoy a life in this world than a life in this world. By the way, this is with a growing economy and a growing population. So whoever tells you that it will be doomsday if the mine doesn't come here, well, I don't know where he gets getting this information, but anyway, I don't think it will be. But anyway, I prefer the bottom one than the top one. I'm going to skip quickly, but the benefits from regulation were 11 trillion and, in terms of premature mortality, and 1 trillion in terms of the rest. Let me skip that. There we go, same stuff. The costs were only $380 billion, and it's over 10 years. That's why it's less, $12 trillion benefits. All right, let me go back to the possible impact of air pollution on camels or in camels. All right, this is how you should be doing a study. You have a baseline condition, current air quality without the project. You have a treatment condition, air quality with project. There's a change. If you see a change in the air quality, then that impacts the population, the exposed population, which causes health impacts, and leads basically to economists to what they call monetary value cost of health. It's all a risk, by the way. Okay, remember that graph? I'm bringing it back. I'm bringing it back because I need it, because I want to show you the health impact effect. So we said basically that if this increases by 1 microgram, the incidence will increase. The pre-mortality incidence will increase by 1.4%. Take that and I'm going to put it into the health impact function. I'll come back. So health impact. This is the health impact function. It says basically that that's the 1.4 in there. Don't worry about where it came from, but I need to show it to you because that variable here, delta y, is the number of premature deaths. Depends proportionately positively to the exposed population. This is the change in particular matter. If I put a 0 in there, then delta y will be 0. If I put a positive number in there, then this will be positive. And if I put a negative number in there, in other words, we reduce it, we'll get less deaths, premature deaths. This is the baseline incidence because we have to start from somewhere. And this is the population. Now, it's very critical that you understand. Population is proportional to the number of premature deaths. It's extremely important that you understand that. Okay, I'll come back to it. And there's other impacts that you can use this function to estimate. But you need different incidence rates and you need different coefficients for that beta. All right, let's go to Kamloops. Let's dump a little bit of PM. Exposed population in 2011, 87,650. That goes in there. If the math is too complicated, ask your children to do it. They'll do it. And there's no model that I used, scientific model I used. Basic stuff. I didn't spend a lot of money, $20,000, $30,000 to buy a computer model to tell me these things. Mortality rate per year, 0.89%. That goes in there. So it's about 777 deaths that occur. Some of them prematurely, some of them because it's time for them to go, etc. Right? Now, I'm going to change PM by 1. Right? And everything else, I know them. That's the other one. This is the 0.014 came from the epidemiological studies. Okay? And then I'm going to get premature deaths per year. How many do you think? Risk. Again, it's a risk. Okay? It may not happen. But is our community willing to take that risk? Is the question that you have to ask yourselves. Risk of 11 extra premature deaths every year in Kamloops. It's the same value that the Kamloops Physicians for a Healthy Environment came up, we're talking about. And I'm pretty happy that I got the same number too. All right. Let's go back in time. Kamloops, 1961. I'm bringing 1961. That's when I was born. And I want to thank the lifelong seniors of Kamloops that told me that the exposed population really wasn't 10,000 because I had 10,000, but 20,000. They corrected me there. So the exposed population was only 20,000. The mortality rate, I use the Canadian figure, 0.77%. Let's increase the PM at 1. By the way, in 1961, we had no clue of these functions. But suppose that we knew them. The number of premature deaths then is a risk of extra 2 deaths from the increased air pollution. And I wasn't here. But today, the risk is 11 extra deaths. Also, the value of a statistical life then was probably a lot lower than it is now because our standard of living has gone up. Therefore, the impact should not, the health cost will not be as big. And this is a risk again. And there was no Aberdeen, from what I hear, and there was no Sakhalin. Had the mine gone, I'm not sure if there was an environmental review process at that time. Maybe there was one. But had the mine gone there, then, was Domtar around? No. All that area of Domtar would be built with houses, probably. It would have transformed Kamloops, probably. All right. So my prediction is towns with small populations will be located closer to open pit mines compared to towns with larger populations. And it has to do with this health impact effect. Somehow, naturally, you'll see small towns close to open pit mines. Larger towns stay further away. Capitals, they stay even further away. I haven't figured that out, but I will soon. I'll tell you why. Okay, so what is the scientific evidence? Why don't we take a tour around the world? Are you with me? Are you tired?
This part's good.
Okay. All right. I'll keep going. There's one here. Oh, there's a town right here. It's in Russia. It's a man-made town. It's for the workers, and it's a diamond. Well, we know all that. That's Salt Lake City. And this is Kalgoorlie in Australia. This is ongoing research that I'm doing with a student of mine and with a few colleagues here. Okay? So I said, let me go see what's happening in the world. Where are these mines located? So I went to this site called www.infomine.com. And they list the mines. As many as I guess the big ones. They won't list the small ones. Here's what I found. Australia, there were open pit mines only. There were 31. Oh, again, this graph. Remember that graph? But this is for a different story. This is the population of closest towns to open pit mines. So this is very, very small towns, like my mother's in Greece, about 300 people, I guess, or something like that, in a nice little village. This is 5,000, population of 5,000, population of 10,000, population of 15,000, 25,000, and 32,000. Here's Kalgoorlie, right? You can see basically that there's a lot more number of towns that are closer, that are smaller, which are closer to the open pit mine. But as the population increases, they go and stay further away, or the mine develops further away. I don't know which one starts from the exposed population. right? This is in Australia. I have the second closest towns also, but it's for future research. But I'm extending the line because there's some, because it's, what's that one there? 90,000. We are an outlier in Australia. The probability that you will observe something like that in Kamloops or more extreme in Australia is 1 chance in 23 million. The odds of winning the 649 is 1 in 13 million. Fool. All right, USA. Same observation. Here we go. A lot of small towns, quite frequent, close to open pit mines. As the population of the closest town rises, less and less and less and less. Oop, what's this one here? By the way, I have the averages here, right? So the average population size is 16,000. The median population size is 9,000. And there's a number of towns is 19 here. That one is basically West Jordan, Salt Lake County. Even that one, minus 16 kilometers away. And the mine was there from 1850. Well, we're unique. All right. There's Salt Lake City. No, that's West Jordan. Salt Lake City is 32 kilometers away. And this West Jordan. So it kind of developed, and actually it's not the biggest employer. It's not even a big employer anyway anymore. They have a very diversified economy, and they moved away from mining. But here you can see that about here you can't see the city moving forward anymore. And that's about, I would say, about 5 to 8 kilometers or so. But anyway, but that's what the price they pay. And it's one of the worst cities in the US in terms of particulate matter. Let me go to Canada. Same thing, Williams, the same thing. Small towns, very close to open pit mines. Don't forget the health impact. It's proportional to the population. The higher the population is, the higher the health impact is. For the same change in particulate matter, because we are more. They have a place, the mines. This is the wrong place here. Williams Lake, Gibraltar, minus 60 kilometers away. Timmins, mine is in the city, 43,000. Fort McMurray, oil sands, 70, 40, 35 kilometers away. What's the second closest city? Edmonton, 500 kilometers away. And there's us. We're an outlier. Let me go, let me put the whole world. Underdeveloped countries. Brazil, Chile, Peru. This is what you see. Small towns close to open pit mines. Bigger the towns, the less frequent you see them. And there are some extreme ones here. You want to know which ones they are? Brazil. Azul Magnesi. Population 140,000. Kilometers from mine, 74 kilometers from the mine. El Abra copper mine, Calama, Chile, population 147, kilometers from mine 59. Yanacocha gold mine, Peru, 300,000 population, kilometers from mine 19. Antofagasta, Chile, Escondida copper mine, population 300. If you asked me copper, what was in mining in general about a year ago, I would say, I know a little bit about it. I have some at home. That's about it. It's not my area of expertise. It wasn't my area of expertise. 151 kilometers. And there's one that I found that is bigger than Kamloops, and it's 3 kilometers from the mine. I will not click there. I don't want you to see what I saw. All right. I'm going to skip this for the issue of brevity. But let me skip this one for the issue of brevity. What I have here is basically, let me do it. I have to do it. Sorry. I spend so much time with my student doing this research. This shows you basically the population of closest and second closest towns. So we got the second closest towns. And they had, on average, they were bigger populations. And this is the distance in kilometers from the towns. And I logged it because it's exponential. The distribution, don't worry about that. It's just math. But you can all fit a line that goes through the best fit line, as I say. It kind of reminds me of the epidemiological studies, the same way. You can find a case where things are pretty good or a lot more die. But on average, so many will die. Well, same thing here. This is the average relationship. It says basically the higher the population is, the further away they stay, or the further away they are. I don't know which one comes first. All right, what is Kamloops? Kamloops is at 11.3 in the log scale because it has 87,000 population, and 87,000 population will lie between 10 and 12 here in the log scale. So it will be about there. So what does this predict? There's about 300 observations here around the world. That would predict basically that the distance predicted should be about 70 kilometers. And at a minimum 10. If you look at Canada, if you look at Australia, Canada, and the US, not the whole world because it included Ghana, etc., then the distance predicted is 128. At a minimum 25 kilometers away. So Highland Valley Copper is okay. It's far away. New Gold is an oddity. Here's a sensitivity analysis because 11 deaths. Well, come on, Peter. Be a little bit more realistic. Maybe it could be less deaths. Yeah, sure, it could be less deaths. And scientists recognize that. What we do is basically we do a sensitivity analysis. And the 5th percentile, which basically says that it says that there's a 95% chance that there will be at least 3 extra premature deaths. There's a very, very low chance that it will be less than 3. But 3 or more, there's a very high chance if particulate matter increases by 1. There's a very, very unlikely chance that it will go beyond 23. Because you're at the upper end of the distribution. Okay? That's what it means. And the mean is 11, which is what we got. Okay. So what did I use? I used as a value of a statistical life 8.4 million, the average of the Food and Drug Administration and the EPA. So an increase in long-term exposure to annual PM by 1 has a social cost from the risk of premature mortality. 11 times what? 11 times 8.4, 92.4 million per year. 25 years, I used a very high discount rate, and the estimate comes to $1.35 billion. So, for Kamloops, $1.35 billion. How about the rest? I couldn't do the rest because I don't have time and I don't have the resources. And but what I did is basically I did what in economics sometimes we do a cost transfer. In other words, we took the EPA study and they found a ratio of 85 to 15. So I assumed that the rest would be 15% of the total cost. Okay? Sorry, I don't have the resources or the time to do everything else. It's just a transfer. Okay, so $240 million. All right. And of course, the minimum would be $450 million. The mean is 1.6 billion in total. And it can be as high as 3.3 billion. Are the benefits of increasing PM worth the cost? These are healthcare costs. I have not gone to ecological costs yet. I won't go. I will give you another lecture. Okay, which path should we take? Health benefits from health benefits of cleaner air in Kamloops. Let's decrease PM by 1, and we can do it. Domtar is doing it. He's helping out. Benefits of cleaner air, $1.6 billion. Cost of cleaning the air pollution, on present value terms, about $50 million. And I got that again as a transfer from the EPA study. Put some trees, build some trees. Bring in health impact of dirty air in Kamloops. Well, it will be the opposite. Health cost of 1.6 billion, plus ecological cost. Can the benefits of more air pollution be greater than these possible external costs? I doubt it very much. So we have some time to discuss it. At the minimum, a full independent health impact assessment of the proposed mine. City of Kamloops creates a task force to conduct an in-depth impact and cost-benefit analysis for a cleaner and healthier environment. I'm volunteering my time, and I don't need any money. Well, maybe. But I want specialists in the area. Good specialists. The gold standard, there's no other standard for evaluation. And the reason is basically, again, all this is huge. The new Afton, I don't know, they just started production. Maybe they'll start mitigation. I don't know. But new Afton and Ajax PM 2.5 emissions will exceed Highland Valley Copper. The gold standard. I'm being nice, actually. We need a standard. Anyway, proposed projects cannot be seen in isolation to New Afton. It's next door. This is where all started. We're still in the 1850s with the gold rush. Wow. If you look at the red stuff, it's the mineral claims. They are a lot more than the protected area. I cannot believe it. I cannot believe it. I don't know what high priority. We changed our liquor laws. We don't touch this. I don't understand. City of Kamloops consider imposing a municipal tax on gasoline. We have to internalize the externality, and the industry, of course, is emitting. We are emitting, however. But let me tell you this thing: if I put a half a cent a liter on gasoline, I can bring into the city, at the minimum, $360,000. From Kamloopsians. I'm sure that all these cars that stop in Kamloops, the foreign cars, then refill, will add another 360,000. And this was half a cent of gasoline. If I put a 3 cents gasoline, the city can get $2 million a year. 3 cents of gasoline. It's called a municipal tax on gasoline. Vancouver has one. They charge 15 cents a liter. If the city of Kamloops puts 10 cents a liter, it's going to cost about $140 a year to a household. I don't know, I pay $140 myself for $200 for this cable that I have all those channels I never watch anyway. I can generate $7 million a year. Over 23 years, it's $160 million. I can beat the 110 that the mine says. And I don't know, I'm not sure where they get the figure from, because I'm not sure they discounted everything, but although I didn't discount it too, so let's be fair. City of Kamloops sets targets to bring down particulate matter. And they should target the most polluted districts in town. there's also a social benefit because the most polluted districts in town are where the lower socioeconomic people live. We should start with the most dirtier place in our house, and everybody will improve. When my house is dirty, some sections of my house are dirty, I won't tell you which ones. I want to say that Lian goes and cleans it, but we clean first the dirtier sections. If we're not tired, we go to the cleaner sections of the city, of our house. Why? Community, we should do the same thing, shouldn't we? All right. Existing industries, including New Afton, should set targets and reduce air contaminants. Unacceptable. Domtar, well done. That's it. I'm going to talk about the ecological damages. It's probably for another lecture now that I'm used to these things.
Do it.
Thank you.
Peter's the only Greek economist I trust.
It's a good one. I want to show you something. Can I? About the Greek? Huh? Should I? Or no? Let's put the questions.
Let's
Okay.
do some questions
Sure.
first.
Sure.
So, Tony, and I'll take the order. A short one, right?
Dr. Tsigaris, could you please comment more directly than you already have, perhaps, on the recent economic study by venture capitalists just getting back to... Okay, that's enough.
I cannot say it. I took a look at it, and then I read the first few paragraphs, and then I just. No, a student handed me in that of a project would probably set either F or take it back and redo it. You cannot do a cost-benefit analysis on such important issue without looking at all costs. And I don't know, I didn't even understand the counterfactual. How did she get it? I don't know the counterfactual because the counterfactual says the mine is in, I don't know what it will be without the mine. The mine is not in, then I wouldn't know the world with the mine. We cannot have both at the same time to see and observe. That's why researchers go and find places where there are mines and try to find compatible places without the mines and compare and contrast them. Then they have the counterfactual. Is the one with the mine growing faster and giving us more economic development and reducing, eliminating poverty? Or is the one without the mine doing the job just as good and maybe better?
Questions, one over here? Just wait, can we get a microphone up there? Okay.
Next question.
I just want to know, where is the federal building that they measure the air quality index?
It's downtown. I haven't gone through it. It's Seymour and something. Seymour and Third.
The roof of Seymour and Third.
Yeah. Yeah, thank you. Is it?
No, it's just
No, I got a question from a fellow economist.
Oh, no, I'll just ask a simple question, sir.
Oh, boy.
You said
Difficult ones.
for 1 microgram increase, there is a mean mortality will be 11. What is the expected increase in microgram 2.5 or 10 if there is an SX mine? So in that case, we can see how many death will be, but it is, in your model, it's only 1.
I don't know. Yeah, it's a good. I don't know. That's why you need somebody in atmospheric physics or that will determine the amount of. First of all, from the ASX mine, we do not know how many tons they're estimating to emit a year. I don't have that information. If I had that information, I can sit down with an atmospheric physicist. I know who, Bob, and we can figure out some stuff. But as it is. The only information I have is from a worst case scenario that Stantec developed and Dr. Schemmer analyzed, which the worst case scenario which would occur in the 14th year of operation would have an impact of 100 micrograms per cubic meter at the site, with a certain assumptions about the layer of the air. The worst case. That's for one day, of course. So you're talking about Strawberry Hill type of fires. Not worse. Yes.
For those who don't recognize the red hair, I'm Dr. Calder, and gave the last talk, and we had quite a bit of discussion after my talk, and to make it really clear, we're using a hypothetical 1 microgram per liter. Just take it, for instance, as 1. There's no way to know for sure what their estimate will be until they do their studies. So we're in this catch-22 of being unable to really directly study. The other issue is that we're just taking 1 for people to understand some numbers. So Peter took 1 microgram and ran it through and came up with 11 mortality, which is gratifying that we're all coming to the same conclusions from the same raw data and science. But we're not saying it's going up by 1. We're just saying if it did, this is what would happen, 11. I got interviewed 14 times after the talk I gave last month, or the month before last, and couldn't make it clear enough that we were just using the hypothetical of 1. If we go up by 2, 22 people. If we go up by 3, 33. Do the math. And the idea that we're only going to go up by 1 is not true. We may go up by more than 1. So just to be really clear, look at the real numbers, because they're not producing them in time for us to do it ahead of the drop of their application.
And again, just additional comment.
I just want to make a comment about the micrograms per cubic meter increases we talk about. And I don't think too many people know what a microgram looks like. So they don't really have a grasp of what it is we're dealing with. If you take a microgram and divide it into typical particle sizes, you're going to have about 100 billion particles. So if you increase the concentration of PM 2.5 in a cubic meter of air, which isn't very big, by 100 billion particles of all different sizes, different shapes, different densities, different chemical composition. A typical person would breathe in about 15 cubic meters of air a day. So if you increase the PM 2.5 by 1 microgram per cubic meter, you're going to be breathing in an additional 1.5 trillion particles a day. And you do that every day of the year. So at the end of the year, that's where your health impact comes from. Some of those particles, somewhere in your system, are going to cause a problem. So a microgram doesn't sound like much, but it really is a big impact.
I think what scares me the most is that the state of California estimates that about a third of their pollution comes from China. That existing right now, and adding any more pollution to the city just scares the hell out of me. I mean, it's just nuts to even think about this.
Yeah.
We'll have one more here. And are there any other questions on the offing?
I've done a lot of work on climate change. Well, quite a bit of work on reading and also research in climate change, and of course then we deal with carbon. And we have priced kind of, we try to find a price on carbon per ton of carbon emitted. And in this area of local air pollution, like for particulate matter and ozone, etc., there's a lot of research also done in that area in terms of economics. But in the future, I plan actually to put a price on a ton of particulate matter, and that way, basically, the companies can pay for emitting it. In which case, basically, they'll say, "Oh, it's costing us." Therefore, the problem is that these are guidelines that just don't.
Thank you very much for your talk today, Peter. It's very interesting. The graph where you have Afton Mine and then over with New Gold and Ajax. I'm not an expert here. I'm just wondering, is there any way of putting a monitor in the proximity of Afton in the same way that Kamloops would be in proximity? So if you put a monitor to see what emissions come from Highland Valley, and so then could we not have a closer estimate of what the particulate would be? Do you understand what I mean?
Yeah, sure. I mean, monitors are important, and to have the monitors, of course, yeah.
Then,
It's not a big investment. It's not a big investment either.
then
Absolutely.
we might have a closer idea.
Absolutely, monitors.
Last one, Tony.
Kind of interesting, you're talking about dust monitoring setups and so on, and they say that there are, I think, 7 or 9 dust monitors, so-called, spread out over the Ajax property. Well, I found one and videotaped it last year, and it is looks like a plywood base with a hockey stick and a platform and 2 plastic jars on it. With some liquid in the bottom, and that's their dust monitoring system.
Okay. Well,
We have a long way to go, but I think we can do it.
a little bird whispered in my ear that you had a birthday very recently.
Well, yeah, yesterday with
Yeah,
with
so
all
with the very best of luck for having a few more anyway.